scientific notation is written as a, you're going to see it's a product. What does the word product mean? What operation? Multiplication of two numbers. Okay, and so the first number is going to be a number that's between 0 and 10. And a lot of times it will be a decimal. Okay, it can't be bigger, it can't be 10 or bigger. The second number must be a power of 10. Okay, we're going to create a number between 0 and 10, and we're going to do that by moving the decimal around. So we're going to count the number of times that we move the decimal. This number will be your power of 10. If your number is greater than 1, if your number is a number bigger than 1, remember what kinds of exponents made the number bigger? The positive ones, right? What did the negative ones do? It made it smaller. So if your number is greater than 1, the exponent will be positive. And if your number is less than 1, like a decimal, the exponent will be negative. Okay, and after we're done, we can always use our calculator, hopefully, to check our answer. Now, sometimes our calculator, because it's in a scientific calculator, sometimes your calculator actually leaves things in scientific notation. So. Okay, number 1 is a really, really big number. So number 1's a really, really big number, and it's 1,850,000. So what I'm going to do is I'm going to create a number between 1 and 10 by moving the decimal. I'm going to put a decimal right here because that's where it is right now. Let's move it. Here we go. Let's count backwards. I'm going to count backwards. 1, 2, 3, 4, 5, 6, and now my decimal is between 1 and 8 because 1.8 isn't 1.8 a number between 0 and 10. If I had gone to 1 earlier, it would have been 18. That would be too big. How many times did I write the decimal or move the decimal? 6, and it's a really big number. So that means that it's a really big number. It's going to be a positive exponent. So 1.85 times 10 to the 6th power. Okay. Now, sometimes, I don't know with these calculators, you could also check your answer at the end to see if it matches. Did you see what I did? Jonathan, you got a calculator. Try it. 1.85 times 10 to the 6. Do you get the same thing that I do? So make sure that it works. And that was what the number originally was. Okay, let's try this one. Would you put a decimal, please, at the end of your number? Would you move the decimal over? Where is it going to go between what and what? 4 and the 2. Okay. So it's 4.2 now. Okay, count for me. 4. 4.2 times 10 to the 4th. Would you punch that number in your calculator? And would you verify, is that the number we started with? Yes, Jonathan's giving me a nod, yes. Okay. 3, ooh, really small ones this time. So in my head, now what kind of exponent is 10 gonna have? A negative. This time the decimal's already there for you. We're still gonna move it. And we're gonna move it between the 7 and the 8. All right, let's do it. 1, 2, 3. So I'm gonna write 7.826. How many spots did I move it? 3, and it's a really, really small number. Or you can think if you're moving the decimal to the right, it's negative, to the left is positive. It's times 10 to the negative third. Punch that into your calculator, please. And verify that you get that. Would you try the last one a minute? Okay, try the last one on your own. I wrote 1.0, or you can just write 1 times 10 to the what? Negative fifth is correct. Because I moved it 1, 2, 3, 4, 5. Okay, now let's go the other way. How do we convert numbers that are in scientific notation to standard form? We go the other direction. That's all it is. So we're going to move the decimal the same number places as the exponent or power. If the exponent is positive, move the decimal to the right in order to make the number bigger. If the exponent is negative, you're going to move the decimal to the left in order to make the number smaller, and you're going to use zeros as your placeholders. Okay, so I guess the kind of the big deal here is just understanding what we talked about over here, okay? That you gotta have some common sense when it's all said and done. If it's a really, really large number, or if you see the power is positive, you should be getting a really, really large number. If you see that the power is negative, your number should be really, really, really small. Right? And you need Eternity, come grab this for me. That's your, we're doing some scientific notation. Alright, so positive, we're moving to the right, negative, we're moving to the left. Are we ready? Are we ready? Where's my... Yes! Alright. 5. Is this going to be really, really big or really, really small? Uh-oh. How do you tell? Exponent's positive. This is going to be a big number. Okay? We're going to move the 7.83. We're going to move this decimal 7 units to the right. So I write my 7.83. Here we go. 1, 2, 3, 4, 5, 6, 7. The decimal is now here. Fill in with zeros. And write your answer. 7830000. Okay. 2.5 times 10 to the fourth. Write down the 2.5. This is going to be a really big number, okay? Would you move the decimal 4 units to the right? 1, 2, 3, 4. Mark the decimal there. Fill in with zeros. So this is 25,000. How are we doing here? Okay. What are we going to do different on this one? Go the other way now, okay? Because it's going to be really small. So I have to write down the number. I should have done a better job of leaving some space in front. I'm going to move it 6 over. 1, 2, 3. I'm redoing this down here. Sorry, guys. Okay. 1, 2, 3, 4, 5, 6. Put the decimal down. Put the decimal down. I moved it 6. Put the zeros in. My number is 0.000008345. What if there's no decimal written down? Well, you have to put it in. 3. Where's the decimal? It's right there. I'm going to now move the decimal 3 units to the left. 1, 2, 3. And put my zeros in. It's 0.003. Okay. Now, putting it all together, let's write this in scientific notation. Right now, the decimal's right here, right? How far would you have to move it? How many spaces to get it between the 5 and the 8? Would you count for me, please?